All right, in section 3.4, we talk about a lot of concepts that are introduced in physics. So if you already had a physics class or currently taking one, this section may make a lot of sense to you and actually shows you like how the calculus ties into another subject. So for this, we have a bunch of definitions. These initial definitions are all physics terms. So we have position. Position we could also look at as like distance from the start or like where we're beginning. It's designated by S of t or x of t. So whenever you see those two notations there, we know that we're dealing with a position. Now, from the position graph, we can, or a function, we can find both instantaneous velocity and acceleration. The derivative of the position function s prime is equal to the velocity. So it tells us the instantaneous rate of change. Remember, instantaneous is at that exact moment. So taking derivative of position allows us to find the velocity of the object at a given moment. If I take the derivative again, so the second derivative of position graph or the first derivative of the velocity, we're able to find the acceleration. So this is the rate at which the velocity is changing. So how fast is it speeding up or slowing down per second? From there, we have speed. Speed is the absolute value of velocity. It is always going to be positive, and technically, like, you can't really get away with saying absolute value of velocity. The big thing with speed, it is always positive. Speed is going to be increasing. Okay, we say it's speeding up when velocity and acceleration have the same sign. So if both velocity and acceleration are both positive, we say it's speeding up. If they're both negative, it's speeding up. And the vice versa is true as well. So if it's decreasing, speed will be decreasing when velocity and acceleration have opposite signs. Some notations here. So we have total displacement. To find your total displacement, it is going to be the difference in your position. So T2, S of T2 would be where we finished. S of T1 would be where we started. So it's the change in position. Average velocity would be change in position over delta T. Delta T is just change in time. So delta T equals T1, not T1, T2 minus T1. It's always final minus initial. And then average acceleration would be my change in velocity over change in time. All right, for this class, we often consider motion to be moving along a coordinate line, a number line, where right is going to be positive, left is going to be negative. So sometimes it may be helpful to go ahead and draw a number line. You're going to have your 0. To the right would be positive, left would be negative. And that's what this bullet point right here is for. If you make a number line summary, it sometimes is easier to visualize what is occurring in these problems. Changes in direction. So if I change from going forward to backwards, it's going to be a max or min on a position function. And then it occurs when the velocity is 0. So if I have a velocity graph, we're looking for where velocity is 0. So when the velocity is 0 and we go ahead and in fact cross the x-axis, it tells us that we have a change in position. Remember, for velocity graphs, anything up above tells me I'm moving forward. Anything down below says I'm going backwards. Right on the line is where either stopped or changing directions. And then lastly, total distance traveled. To do that, you want to make your number line summary, and we are just figuring how far did I walk all together. You're adding it all up. So whether it's forward, backwards, whatever, distance is always a positive. I don't care if we're going forwards or backwards. Distance is always a positive, which is also known as a scalar. Remember, vectors are where direction matters. Scalar, don't care about direction at all. So jumping right into a problem. They give us example 1. They give us the position function right here. It says it equals negative 0.4 t squared plus 3t plus 4. They give us a graph. They give us the domain. They said we're going from time 0 to 10. Okay, a couple things they want us to find here. First off, they want the velocity function. With this, we could go one of two routes. We could go SVA, or when I taught physics, it was PVA, position, velocity, acceleration. Working your way down the line, you are taking derivatives. Okay, so to get my velocity function, it's the derivative of the position function. Doing so is going to give me negative 0.8 t plus 3. To get to acceleration, it's one more step down, so we're taking another derivative. It's going to give me an acceleration of negative 0.8. From here, there's one more thing they want, and that is our change in t, delta t. Over the whole domain, my change in t would be 10 minus 0, which is just 10 seconds. All right, it went ahead, gave us a kind of coordinate plane here, kind of. I'm going to go ahead and graph the position function on there. So I got s of t, and then we're going to have time on the x-axis. Always going to have time on the x-axis. From here, making a rough sketch, I got 1, 2, 3, 4. Got a y-intercept of 4. Okay, I can put a dot there. And honestly, I'm not going to graph the rest of it. Like, we're going to use the calculator. So typing in, I go ahead, go y equals, I got negative 0.4x squared plus 3x plus 4. Go ahead and graph this. So on our graph, we care about a couple things here. One would be the max. Okay, I want to know what is the maximum there. So using your calculator, you can go second calc, and then we're going down to max. It says left bound, so I hit enter. It says right bound, so I hit enter. And it goes ahead and gives me the maximum as 3.749. And then the height is 9.625. So I'm going to go ahead and do that. I'm going to label it. So we're going up. I'm going to come down. I'm going to say right here, we're at 3.749 and then 9.625. With this, we are not rounding. I'm going to 3 decimal places, and I'm going to leave it alone. Okay, so leave the rest there. The other thing I'm going to care about is when does it cross the x-axis? Reason being is I know when my position switches or goes over this x-axis, I'm going from being in front of the starting point to behind it. Across the x-axis at a 0. So I'm going to second calc 0, and then I go left, I go right, and I get my 0. So just drawing the graph down, it looks something like this. So we are at, right there, it's going to be 8.655. 0. Last point I'm going to want on here is going to be the endpoints. So I already have the y-intercept. My endpoint over here, when I go ahead and plug in 10 for x, we're going to get a y value of negative 6. So let's see. I got, that shouldn't be a negative. That should be 10 comma negative 6. That'll be my endpoint. So there's my rough sketch for my position graph. It represents all the information that's key. So I got my starting point was 0, 4. I got the max. I got the 0. I got the endpoint. All right, from here, well, I know at what time does the object change direction? So you got to like place yourself in the problem. Think of the scenario, okay? So right here, object starts out at a position of 4, 0 seconds. It's going forward, okay? It's going away from the starting point. We're going up. I get all the way up to a position of 9.625, and then all of a sudden it turns around and goes back towards the starting point. So my time would be 3.750 seconds for that. For B, they want you to generalize where will you find direction changes on position graphs. It's going to be the max or min. That's it, the max or min. All right. C, they want you to find average velocity. So average velocity is my change in position over change in time. So our final position here, we finish up at a position of negative 6, and I started at 4. So we have negative 6 minus 4. Down below, my change in time, 10 minus 0, negative 10. So doing this, we're going to get negative 10 over 10. Gives me negative 1 meters per second. Make sure if there are units, include them. All right, from there, they want to find position, velocity, acceleration at these different times. They want S of 0, S of 10, so on and so forth. You are going to go back and use these functions right here. We're just plugging in. So if I plug in 0, we're going to get 4 for my position. Plug in 10 to the position, and get negative 6. And these are meters. Velocity, plugging in 0, I'm going to get 3 meters per second. Plugging in 10, I am going to get negative 5 meters per second. And then acceleration, plugging in 0 for acceleration, well, there's nowhere to plug in, so it's just negative 0.8 meters per second squared. And then there's nowhere to plug the 10 in, so negative 0.8 meters per second squared. E, they want to know, is the speed increasing at t equals 0, t equals 10? So let's look at t equals 0. Okay, we need to look at velocity and acceleration. We'll have a positive velocity, negative acceleration. Since they're opposite, it's going to be slowing down. Reason being, because v of 0 is positive, a of 0 negative. Looking at 10 seconds, I got a negative velocity, negative acceleration. Since that is the case, we are going to say that it is slowing down. I should have said decreasing. Over here, we're going to say it is increasing or speeding up. Reason being, because v of 10 is less than 0, a of 10 is also less than 0. They're both negative. So if the signs are the same, we say that it is slowing down. Or sorry, speeding up. Signs are the same, we are speeding up or increasing our speed. Okay, last thing we want to do here, not the last thing, the last couple of things. Find all the times when velocity and acceleration are 0, verify graphically. If I go v of t, and I were to go ahead and graph that function, we would start up here at 3, and then we're coming down. To go ahead and find that 0, you could go ahead and type that function in. So it'd be negative 0.8x plus 3. That's my red line. When I go ahead and graph this, you're going to notice that it matches up right with the peak of our position graph, right at the maximum when we change positions. I can go ahead and find the 0 on that. Wrong curve. Find the 0 on that. And if I do that, it's going to be the same time. Delete 0. It's going to be 3.750. So our time would be 3.750 seconds. As far as the acceleration goes, if I go ahead and graph that function, it would just be negative 0.8. Go ahead and graph it. It's the black one. You look at it, it is a horizontal line all the way down here. So that's my a of t versus t. That acceleration never changes. It's constant. So it never equals 0 for that. All right, G, want to know what is the relationship between the time when the velocity is 0 and the corresponding t value on the position function. We're going to say they're the same. I'm going to say v of t equals 0 when s of t is a max. Okay, and we showed that right here. They matched up, all right? Our position function changed as the velocity function went to 0. There we go. It's right here. 0, they line up. Lastly, it says generalize when you will find direction changes on velocity graphs. It's going to be when v of t equals 0 and changes sign. So you actually have to cross over the x-axis there for that to occur. All right, last two. They want to know what is the total distance traveled from 0 to 10 seconds. To do this, I'm going to make a number line. So looking at my position function, okay, position function, I started off at a position of 4, so I'm going to throw 4 down there. From there, it walked forward, or the person, whatever it was, walked forward until it got to 9.625. So went forward to 9.625. That person or object then turned around and walked all the way back to -6. Okay, so we want to know what is the total distance that person walked. Well, this first part right here, from 4 to 9.625 is going to be 5.625 meters. And then going from -6 all the way to 9.625, the distance from here to here is going to be 15.625. Remember, distance is always positive. So go ahead and figure out the total distance. We just add the two of them together, and it'll be 21.25 meters. We want to describe how we found the total distance for an object that traveled. Well, we just did it. Okay, made a number line, listed out what was going on from our position graph, and then distance is always positive, so I don't care about direction on that. So we added the absolute values together. So that's it for 3-4 day 1.